This is the Philosophy of Evidence, Part 3. I want to remind you, everything I'm saying might be wrong, so don't believe it just because I said it. We're going to talk about the possibility of evidence being mistaken. So, if we refute a theory with evidence, but the evidence wasn't correct, that's kind of a problem. What can we do about that? In science, one of the major techniques is called repeatable experiments. The idea is you carefully keep track of everything you do, and then you could do the same thing again later, or someone else could do it. By repeating the experiment, we can see if we get the same result. This helps us make sure that our results weren't just a fluke. And it gives people the chance to look at everything we did and look for mistakes in it. So when you repeat an experiment, either you get the same answer the first guy did, or you don't. If you do get the same answer, it helps create agreement between scientists. Because the one scientist got the same answer as the other, he sees the guy's right. So it helps settle disputes, it helps settle disagreements. On the other hand, what if you get a different answer? Then we know that the first experiment might have been mistaken, or the repeat try could be mistaken, but we know that we need to investigate a lot more. So we've learned something important there too. In general, the way to deal with mistaken evidence is to be open-minded about criticism. So, if someone says that our experiment had a mistake in it, we need to listen to them. We need to know that we're not perfect. And we need to investigate it and try and figure out what's correct. We also need to try and look for criticism of our own experiment and our own ideas. Not just wait for other people to tell us what we did wrong. So whenever there's some sort of argument against what we were saying, we need to address it. We're going to either have to come up with some reason it's mistaken, or accept it. So in science, keeping this sort of open mind, but also a critical mind, is important, and it helps us deal with the possibility of mistakes. So what if our evidence had a mistake? Either somebody knows about the mistake, so it's a known issue, then someone can say so, and no harm is done. Or it's not a known issue, it's something that nobody understands. Then we're not going to catch the mistake right away, but we shouldn't be too worried about that because no system is going to catch mistakes that nobody understands. The good thing about mistakes is that they always have some reason behind them. There's some sort of explanation of what went wrong. Something happened. So, we can always learn from our mistakes. And we can always look for mistakes. We can look for things that might cause mistakes. So there's always the possibility of making progress. And whenever we do find out about mistakes, about possible sources of error, then we understand the field better. We're getting somewhere. Fallibility is a general principle that says anything might be mistaken. It's common sense. We're not perfect, so we could make a mistake, and we might not realize that we did. That happens all the time. Some people mix up fallibility and skepticism. Skepticism says we don't have knowledge because we can't prove anything is absolutely true. So do you see the difference? Fallibility is saying there might be a mistake, so we should keep an open mind. Skepticism is saying there might be a mistake, so it's worthless. So it's important to keep in mind that we might make a mistake, but that doesn't mean we should just be a complete skeptic about everything. What's important about fallibility is that whenever we come to a conclusion or we have some evidence, it's not the end of the issue forever. We could always revisit the issue. So fallibility isn't a bad thing. Skepticism would be a bad thing, because it's sort of saying we don't have any knowledge, how can we live our lives? But all we really need are good theories that are useful, and they're the best theories that we know about so far, and that's good enough. So the lesson here is that evidence could be mistaken, but we shouldn't be overly concerned. Just the potential for errors doesn't make our evidence useless. What we should be more worried about is if someone actually has a doubt, or sees a problem, or there's some sort of suspicion. When people think there's an error, even if it's someone else or us, then there's something worth looking into. But if no one thinks there's an error, you shouldn't be too concerned. Some people try to look for perfect foundations. They want absolutely certain premises and evidence, and then they build up a whole structure, and they say the whole structure has to be true, because all the parts are true and all the connections between them are true. If you're trying to do something like that, fallibility is an enemy, because you're looking for certainty and you can't have it. But that's not how science works. That's not what we're doing. We're accepting fallibility, and science does accept fallibility. That's why it does things like repeated experiments. So what about learning from mistakes? Every time there's a mistake in our evidence or in our theory, there's a possible source of error. So that's an important discovery. We're learning new knowledge. Let's look at two theories to compare them. The first theory says all balls are red. The second theory says all balls are red, but sometimes people think they found a green ball because of paint, tinted glasses, faulty color sensors, or something else. But whenever those things happen, it's just a mistake. As you can see, the second theory has more knowledge in it. The second one is an improvement on the first one. It shows how we can learn things by dealing with mistaken evidence. The extra details aren't going to be relevant all the time. We don't always have to think about them. But it's good to know them and to be aware of them and to be able to look them up if they're relevant. So, even though the painted green balls were mistaken evidence, we were able to learn something, we were able to make progress. And notice how when we went from the first theory to the second theory, we were changing the theory. The first theory wasn't as good, and then we revised it. So whenever we deal with contradictory evidence, we're always going to improve our theory. The main ideas about dealing with mistaken evidence were to use repeatable experiments to try to find errors in the evidence. and we should keep an open mind to criticism and even look for criticism ourselves. That will help us deal with mistakes both in our evidence and in our theories. We also talked about the consequences of mistaken evidence and how it can help us learn. We talked about fallibility and how that's not skepticism. I hope that all made sense.